Math 1 EOC Practice Test number 16. Jamie deposits $627 into a savings account. The account has an interest rate of 3.5% compounded quarterly. Write the function that gives the amount of money in dollars, J of t, in Jamie's account t years after the initial deposit. Write your answer in the space provided. All right, so I went ahead and pulled up the formula sheet, and on the formula sheet it gives you the formula, so you don't have to have it memorized. It's not a bad idea to have it memorized, but here's the formula that we have. Okay, so this is compound interest, and that's what we're doing because it says compounded quarterly. All right, so we need to just look at what information we have and plug it into the formula. So I'm not going to put anything in the space provided until I have my formula that I want to use. So I know that I've got it crafted the way the question asked for it. So it says Jamie deposits $627 into a savings account. So that is the principal. So we have the principal is $627. And then the amount has an interest rate of 3.5%. All right, so we're going to have 1 plus, and my interest rate is where this goes. But this is a percent, so we first need to change it to a decimal. So if I say 3.5%, to move this to a decimal, it's going to be 0.035. All right, so on the top here, where it's R, our interest rate, 0.035. All right, N is the number of terms. This says compounded quarterly. Quarterly means 4 times a year. And then N times T, so we take the N, the same N, 4, and T is time. We don't know in Jamie's account T years after initial deposit, so we don't know how much time is going to be, so we're just going to leave that as T. So it says write a function that gives the amount of money in dollars J of t. So they want us to call our function J of t in Jamie's account t years after the initial deposit. All right, so we have crafted our equation based on the formula and the information given. So now I feel good about putting my equation here. So J of t equals $627 times 1 plus 0.035 divided by 4 raised to the 4t power. So that is the answer for number 16.